So we're going to find the inverse of matrix B, and first of all we're going to do it without the calculator. So remember yesterday we had to do this, actually on Friday. What did we do first to find the inverse of this matrix? Abigail?
Switch A and B.
Okay, but even before we do that, what did we have to do? Right. So before we do any switching, we find the determinant. It's going to be negative 18 minus negative 35. So that's going to give us 17. And so now she's right. She said we had to switch A and D. And we had to change the signs on B and C. And then we have to divide through by that determinant. And so that should be the inverse. I had already kind of showed you guys how to do this, but just in case you didn't quite get it, here's what we do. We go to our matrix. We go over to edit. This matrix B is a 2 by 2 matrix. We have negative 6, negative 5, 7, and 3. And now we're going to go back to that matrix, and I put mine into A, so that's where it is, and then I just have to hit this X to the negative 1 key right here. So I hit that, and then I hit enter, and then I want to change them into fractions. So I go under math, and I want to frac. So we get this. So there we go. That's what we end up with. Okay? All right, so we've already done all of these things, just finding the inverse of a 3 by 3. You know, you just put it in as a 3 by 3, find the inverse. Determinant of D, do you remember where determinant's located? It's under matrix as well. So if you go under matrix and go over to math, there's your determinant. Okay? So that's where all that stuff is that we might need. So we might want to jot this down to go under math to find determinant. All right, but let's go down to the good stuff now. So to solve a system of equations, we can use this RREF. This stands for reduced row echelon form. When a system of equations can be rewritten as a matrix in this form, so if we can get a system solved, like this would be an example of a system. All of these things here we see are systems. So if we can get it rewritten like this, then that's going to mean that x equals 9, because this is in the x position, and this is going to mean that y equals negative 3. See, this is really saying 1x plus 0y equals 9. So that's why it's telling me x equals 9. This is 0x plus 1y equals negative 3, and that's why it's telling me y equals negative 3. So before we had graphing calculators, students, mathematicians, everybody would have to get matrices representing the systems of equations. They would have to get them into this reduced row echelon form. Here's how they would do it. They would multiply a row by a constant, and then they would add or subtract it to another row, and then they could replace it by that result. Now the calculator can do all that work for us. I will not expect you to do the reduced row echelon form by hand, but I do want to show it to you because it's a pretty cool thing. See, let me give you an equation like this. This is something that's easy to solve. I don't even have to really do much to it, because what happens if I add the equations? What do I get? 4x equals 8, and so what does x equal? 2. And then to find y, I just substitute it back in. So if I have 2 times 2 is 4, so 4 plus y has to equal 3, y would have to equal negative 1. But if this hadn't worked out so easily, you know how you could have multiplied this by, say, like let's say this had been a minus 2y. Well, I could have multiplied this whole equation by 2 and added it to that equation then. You know how you do that? So that's kind of the same thing as reduced row echelon form. I'm going to do this problem with reduced row echelon form, pretending we don't have the capabilities to do it on a calculator. Here's the way I'd set up the matrix. 2, 1, 3, 2, negative 1, 5. See what I'm doing? I want to get a 1 in this spot. I want to get a 0 here. I want to get a 0 here, and I want to get a 1 here. The easiest thing to do would be to get a 0 right there. Do you see how if I just take this equation and I add it to that one, I would get a 0? So I'm going to take this and add it to that. So 2 plus 2 is 4. 1 and negative 1 is 0. 5 and 3 is 8. Okay? So I have my 0 there. So I'm going to just rewrite my second equation because I didn't do anything to it. Now, I actually want to have, though, just a 1 there. So now what could I do to all of this equation? I could do just divide by 4, right? So I'm going to divide by 4. So I've got the first part like I want. I want to have 1, 0. Here I want to have 0, 1. So I don't have that yet. So I want to get a 0 in this spot. What would I have to multiply this by so that when I add, I get a 0 in that spot? I want this to be a negative 2 so that when I add, I get a 0 when I add them together. So I would have to multiply row 1 by negative 2. And then I would have to add that to row 2. All right, so I know this is tough, but just kind of watch. So I'm going to multiply all of this by negative 2. So that's going to give me negative 2, 0, and negative 4. And now I'm going to add that to my second one. So my first one I don't want to change. I just keep it as 1, 0, 2. When I add these two, I get 0. Add these two, I get negative 1. Add these two, I get 1. But remember the form I want? I want it to go 1, 0, 0. What do I want this to be? Just a 1. So I don't want to change the top, but I'm going to multiply the bottom by negative 1. And now I can see that x equals 2 and y equals negative 1. Aren't you glad we have the graphing calculators now? Because that's the way people used to solve systems, was with this reduced row echelon form. But now watch what we can do. Get your calculator. Go to your matrix. We're going to go to matrix, edit. We'll use matrix A. Here's the first step, rewriting it in this form. So what's the dimensions of this? It's a 2 by 3. I just put it in. I quit. And now I have to go back to my matrix. I have to go over to math. I have to go to the Rref, which is way down there. I get that. And then I have to go back to my matrix and say, find the reduced row echelon form for matrix A. And see what it gives me? The same thing that I found by hand. It does all that arithmetic on its own. And it finds out then that x equals 2 and y equals negative 1. So we did that a bunch of different ways. We did that with elimination. We did it with reduced row echelon form. We can also do it with inverses. Let me just quickly show you inverses. To do this with inverses, I would take this matrix here, which is 2, 1, 2, negative 1, and I would have to do the inverse of this matrix times that matrix. Do you see what I'm doing? Here's the x and y values, so I would have to do the inverse of this times that. So just kind of watch how this would work. You don't need to follow along on your calculator. I'd go to matrix, and go over to edit. I put in a 2 by 2. I have 2, 1, 2, negative 1. I go back to matrix. I go over to edit. I need to go down to matrix B. This is a 2 by 1. I need to put in 3 and 5. And so now what I do is I do matrix A, and I want that to be the inverse of that times matrix B, and that's also going to give me that answer, that x equals 2 and y equals -1. You see how we have all these different ways that we can solve problems. All right, flip over on the back now. So let's first do this one by using inverses. Now I did that last one quickly with inverses. I'm going to show you the more formal way to write it now. It should go 4, 3, 2, 1. What we're solving for is x and y, and that we want it to be equal to 1 and 5. See what I'm doing? 4, 3, 2, 1. We're solving for these variables of x and y. We want it to be equal to 1 and 5 for whatever values we get for x and y. So to solve this, I have to do, I'm going to call this A and this B. X, y is going to be equal to the inverse of A times B. So let's get our calculator now. Go to matrix, over to edit. We have a 2 by 2 for matrix A. 4, 3, 2, 1. Quit. Go back to matrix, over to edit, B. It's a 2 by 1. And we've got the numbers 1. Oops, mistake, hold on. 2 by 1. We have the numbers 1 and 5. So now I have to go back to matrix. I want matrix A, the inverse of that, times matrix B. And there we go. So x equals 7 and y equals -9. So look at the difference between using inverses versus using RREF, reduced row echelon form. If I'm doing this with reduced row echelon form, I don't need to have two matrices of A and B. I just make one matrix. It goes 4, 3, 1, 2, 1, 5. So now we're going to go back to our matrix, over to edit. What's the size of this matrix, guys? 3 by 2. No, it's not. 2 by 3. So put that in. All right, so after you get it in, quit, then go back to your matrix, over to math. I bet we can go this way too. Yeah, a little faster going up to get to it. Our reduced row echelon form of matrix A, and it gets the same answer. So we get this 1, 0, 7, 0, 1, -9. And so what that means is that x equals 7 and y equals -9. Same answers. See the difference? All right, choose your favorite way. It says to use RREF, but if you want to use inverses, you can. Let's see if we can all get the same answer on this. so we should get these answers. So that's telling us then that x equals 44 thirds, y equals negative 52 thirds, and z equals 29 thirds, because those are the missing variables. Did you guys get that? So you can see how nice it is now to be able to do this on the calculator instead of trying to get it into that form on your own. That would be very challenging to do. All right, anybody have questions? Charlie, did you get it?
What?
Did you get it?
Yeah.
Oh, I thought you said no. All right, good job, guys.